Hey guys, this is a quick video on the patterning work that we've been doing, just in case anyone didn't do this in grade 8 and you're feeling really lost. Okay, so in school, sometimes we use these little tiles, and since we're not really in person, I've just drawn the tiles on my iPad so that it's like virtual tiles. So you can use these tiles to create patterns. You could use anything. You could cut up little pieces of paper to be your tiles. I've color-coded my tiles just to make it even easier. So these tiles, or these numbers, are what we call a term number or a position number. Maybe that's what I've actually been calling it, term number or like position number. So it's just like, oh, in the first position, we have 3 black tiles and 2 red tiles. In the second position, we have 3 black tiles and 4 red tiles. So it just like shows what happens at each part of the pattern. You could even predict what would be happening in the fourth pattern. Well, I'm predicting, since there's 3 black tiles in every number, I'm guessing there's still going to be 3 black tiles. Okay, let's take a look at the red tiles. Here we've got 2 red tiles, then we've got 4 red tiles, then we have 6 red tiles. 2, 4, 6. I'm guessing we're going to have 8 red tiles in the fourth pattern, or the fourth term. So it's just like you just see how the pattern is growing or shrinking. In this case, it's growing. So it looks like the red tiles are kind of like increasing by 2 every time, right? Like they're getting 2 added to them every time. Whereas the black tiles, they're just remaining constant at 3 each time. There's just 3 black tiles. So what we like to do with this information is to write what we call a rule, which will be translated into the word equation. So the rule always starts with, we're trying to predict the number of tiles we're going to have at each position number. The number of tiles. So see how in position 1, we have a total of 5 tiles. In position 2, we have a total of 4 plus 3, so 7 tiles. In position 3, we have a total of 6 plus 3, so 9 tiles. In position 4, we have a total of 8 plus 3, so 11 tiles. So we're trying to predict the number of tiles with our rule. So we always write our rule as number of tiles is equal to, then we like to use the variable position number. Then we usually have what's called a multiplier. So it'll be something. And then we have what's also called a constant. So I feel like the constant's really easy to see here. What's constant in every position number? The tiles, right? Or the tiles, the black tiles. There's always 3. So that is called our constant. It's also known as the y-intercept, or the initial value. It's what you're starting with. You're starting with 3 tiles. If we were to back up to position 0, like you know how it's 1, 2, 3, 4. If we were to back it up to position 0, we would only have 3 black tiles. So that's our constant. We're always going to have 3 black tiles in every position. Okay, and then our multiplier. So look what it's going up by every time. It's going up by 2 every time. And you can see, like you can test this out, but position number times, let's say it was 2. So 1 times 2 is equal to 2. That gives us our red tiles. Plus 3, which is our constant, would equal a total of 5 tiles, which is what we have. So the rule for this pattern is position number times 2 plus 3. So that's how the patterns work. You have to kind of see what are the red tiles increasing by and what are the constants. Now it's way harder to do when you don't have them color-coded. But so far, I've just been color coding them for you. So it's easy to see the constant. So I'm just going to write that. So we call this guy the constant because it always stays the same. And we call this guy the multiplier. So to relate the, okay, so wait. Then we could actually graph this scenario. I'm just going to do a rough sketch. So number of tiles, so the whatever is on this side of the equal sign always goes on your y-axis. So number of tiles. Position number is going to go on the bottom. That's because the position number is like our independent variable. It's just happening, and it will predict the number of tiles. So it will influence the number of tiles. So then we'll just go up by 1, 2, 3, 4. You always start at 0 on both axes. And for tile numbers, since I'm going like 5, 7, 9, I'll maybe just go up by like, I don't know, like 3s, 6, 9, 12, 15. Okay, so I made my graph. Now I just have to plot the points. So in position 0, I will have 3 tiles, right? That's my constant, also known as my y-intercept, or I also could call this my initial value. It's my starting amount. Okay, then in position 1, I've got 5 tiles altogether. 1, 2, 3, 4, 5 tiles. So in position 1, I'll just graph 5 tiles. In position 2, I have 7 tiles. So like here. In position 3, I've got 9 tiles. Position 3, 9 tiles. In position 4, 11 tiles. So you can see our relationship is going up in a straight line. It's a linear relationship. So we write that as number of tiles equals position number times 2 plus 3. That would be the equation. But another way to write, we were trying to relate this to like y equals mx plus b. So I taught this lesson on like, remember, y equals mx plus b. So we're trying to say like the multiplier is like your slope. It's like what your pattern is increasing by each time. So we can tell our pattern is going over 1, up 2. It's hard to tell on this graph because of my scale and stuff, but over 1, up 2. So it's increasing by 2 each time. So y equals 2x plus, and then b, that's our initial value, or our y-intercept. So 3. And x and y just represent, this is the x-axis, so it represents position number. This is the y-axis, so it represents number of tiles. So we can also write this equation as y equals 2x plus 3. Or number of tiles equals position number times 2 plus 3. Cool. So that's basically how patterns work. Oh, and I can even predict one more thing. Like this page is getting really busy. But like, let's just say I wanted to estimate how many tiles would there be. We want to know the number of tiles in position, I don't know, pick a number, 20? We're not going to draw 20 position numbers. We made it all the way to 4, but I don't want to get to 20. So that's how I can use my equation. So it says number of tiles is equal to position number, that would be 20, times 2 plus 3. So 20 times 2 is 40 plus 3. There would be 43 tiles at position 20. So equations are kind of handy for like predicting how many tiles there will be in a future position number, because you don't want to keep drawing all these tiles, or you don't want to keep adding by 2. Like you can see the patterns 5, 7, 9, 11. You could keep that going, but what if I asked you like position number 1,000? It's way handier to use this equation. All right. The end of the video.